Hi everybody. So we are going to observe how to plot graphs. So let's begin like this. I have just already drawn the raw data table, and this is what exactly you might have also got. Okay, so 20 gram, and then you got 3 times displacement, and you have finished all those things. Then you found the average of the displacement here, and once you got the average, then you calculated the force, which was mg, so you multiplied this with g, and then you found the k, the spring constant. And anyway, your answers are different from mine, but I'm just taking an example actually. Okay, the least count here is not correct. I'm not going to take this, so I'm just going to take it as 0.01, because otherwise I can't see the error bar in my case. So I'm just going to keep it all of them as 0.01 only. Now let us say, yeah, done. Okay, now what we are going to do here, we are going to copy this complete table into Excel. So I have already copied it here, and once I've copied it here, I found the average actually from here. You see, you can find the average from here, this button. So you have to, all you have to do is, let us say this is not there, delete, and then I have to just select and take one extra, and then just say that okay, you find average. So it gives you average 0.233, right? So I did that for, see here, I've done almost all the places, this, then this, and all of them are average. So that's what we do. So once you get the average, your average, then you are ready to rock. Now you pull out your mass, average, displacement, these values. I'm keeping only 2 decimal points, so I wrote here, and then you find the force, which is mg, and then your k. Okay, then the error. Now I'm just going to pull out the force separately here, see, and then I'm pulling out the displacement, because I have to plot a graph between force in the x-axis and displacement in the y-axis. This is my independent, this is my dependent variable. This is independent because I am changing it. Now once the graphs are plotted, let me completely delete this. I'm just pull out this, and I'm going to say delete. So I'm not going to use this graph. I'll show you how to draw that. So select it, go to insert, go to scatter, go to the first one, and then just keep it in a comfortable place, and then click here. See, you just need to click that. So you can get the axis. You just go here, and then you say it is displacement / meter, and the error is your 0.01. Okay, so done. Same thing, go here, and then you select this, and then you say this is your force, and then that is in Newton. Okay, right. I don't require this, so I'm going to just delete it. Delete. Okay, now my everything is ready, so I'm just going to go here and put a title here, that this is a spring constant graph, and then I'm going to go here and right click. Once you right click, you are going to get so many things here. Just click in the add trend line. Once you get the trend line, it should be linear here, because I know the relation. I will say display equation, and I will see how much I have to pull it back. I have to pull it back by 0.2. So I will just type here 0.2. So once I do that, I will close it. My line will touch this end. So I will just go here, right click, and then I will say again add minor axis. Then I will right click here also, and then I will say add minor axis. Okay, now once this is ready, I'll just take the graph, Control C, and then I will go to Word, and then I will paste it. So this is the graph. Okay, I have already pasted it, and I have labeled also that this is the best fit line on the gradient. So your points are ready now. Okay, let me have a look at the graph there once again, because I did it twice. Oh, okay, so this is different, appearing different. I'll delete this also, and I will delete the second one also, second graph also. Okay, ready. Now come to the first graph. So I'm going to go to Excel, and I'm going to copy this graph, Control C, right click, copy, and then come here, and then just say right click and paste. Yeah, your graph is ready. Now all you have to do is just pull the graph down as much as you can. I think I put it in the wrong place. No, graph 1, correct. So this is okay. Now pull it little more actually, because it should be 2/3 of the page, and then you write something about the graph. The graph clearly indicates a linear relationship and all those things. It is not passing through actually 0. So there is a small systematic error here. So you have to write that also, may be possible here somewhere. Okay, so there is a systematic error, and then that's about this graph. So this is done. Now I will go to second graph, which is the error analyzing graph. So I will go back there and I will put the error bar now. So I will click here, right click, layout, then go to error bar and say more error bar, and then you go to the fixed value and put there your error value. So 0.01 is what we are putting. So close, right? And then I'm going to click on the horizontal one and I will simply delete them. So I'll be left with only the vertical, but I can't see them. So I will go to format data and then I will say marker fill and I will say no fill. So no need to fill. So I can see them now clearly. Now this graph looks pretty good. So what I'm going to do is I'm just going to put it little long so that I can see, I can see the lines at least. And I'm going to now plot the minima and maxima, which is very important. So let us plot minima and maxima. I am going to first, in the x-axis, I'm going to take the first point, which is 0.2, and the last point, which is 0.6. So I brought 0.2 and 0.6, which is not exactly 6, but 0.59 from this value if you look here. Okay, this value. So I have written it twice, see, once and twice. Okay, now what I am doing, my error is this much. So in 0.02, the value of the displacement is 0.23, this one. So I am going to add once 0.01 and subtract once 0.01. So when I add, it becomes 0.24. When I subtract, it becomes 0.22. So okay, so I added here, I subtracted here, and then what I am doing, once I add here and once I have subtracted here, then I have to do the reverse. So I have to subtract here and then I have to add here. This is the funda. So the lines will touch from bottom to top and then top to bottom. So I have done that job, I have done this job. Now I am going to right click here and then I will say select data, and then I will say add, then I will go to x-axis, I will select the x-axis, then I will go here, I will backspace and delete, then I will select this also there, and then I will say okay. So you can see a red color here, right? Now what I will do is I will again say add, again I will go to x-axis, then I will go to your this one, and then I will again backspace, delete, and then I will go to this one, then I will say okay. Okay, so I have plotted them. So red is 1 and green is 1. So let me say add trend line, and then I will say display equation. Okay, and meanwhile I'll just write here best, because this is my best fit line. Okay, gradient. So I'm going to be very careful with that. Okay, once more, I'm not going to. Okay, so we close this. I will just control Z, okay, and control Z. Okay, control Z. So line is out, and I will first write here, because this is my best fit. Otherwise I will make a mistake, I will not know which is best fit. So this is my supposed to be the best fit, I will keep it here. Okay, now I will click here and then I will right click and say add trend line, then I will say display equation. I will pull the equation here and keep down just below this. Then I will go to the red one. I think wherever way I can do. It's not clicking here. Yeah, done. So I will right click and say add trend line, then again I will say display equation. So done. So I will pull that equation also here now. Okay, now if you look here, this is smaller one, this is the larger one. So I will take this one as the max gradient, and this is the smaller one, so I will take it as minima gradient. Okay, so you have all the three gradient now with you. Now I will copy this graph and take it back there. Control C, sorry, you can do even this also. So copy, and then you go here and then you just insert here, paste. So you just paste it. Yeah, done. But again, make sure you have pulled the graph and made it quite big enough for somebody to see it clearly. Yeah, okay. Now this is the formula that we need. Error analysis, maximum gradient minus minimum gradient by 2 by best, and then you have this times 100. Okay, so I'm going to do that actually. Now let us check this. So it is 1.5897. So 1.5897. This is 1.4872, 1.4872. Then this is 0.2674. This is not 0. This is 1.4659. So 1.4659. This is a mistake here. This is old one. What was it? It was 4659. Okay. So 4659. Okay. And then I think we are done here. So I will just calculate using this calculator. So it should be something like, say, cancel. So 1.5897, and then I have minus 1.4659, 48 and then 72, and then I can do equal to, so it is by 2 equal to, then by 1.4659, and then I will say equal to, then I will do times 100, so it will give me 3.5%. so it is about 3.5%, and this is your error from the graph, which is also explaining the random error, how much your data can actually jump up and down. But there is a problem here. The problem is that still we have some lines, error bars, which are not touching actually. So you have the freedom. If you're not very happy, you can actually move this line, shift the line little up, down, if possible. If not possible to touch, then you need to explain. So you have to give an explanation here, explanation of why all error bars are not, or why the line is not passing through all error bars. Okay, I think that should be fine for you actually. Okay, yeah, so this is all about plotting graph. I think this is not a very big deal. You can easily plot, follow this exactly how I have explained, and calculate till here. So that should be pretty good enough for your DCP aspect of plotting the graphs. So have a nice time. Make sure you have all this data and copy them in the Word also, one by one, because you need to have, at least you see here, you need to have a raw data, and then you definitely need to have this. Make sure units are always there. Make sure you have the error, okay, at least for the one which you have measured. Okay, mass you don't have just now, you have taken it standard, so maybe you can write here also standard, so you don't have error here, that's right. Okay, yeah, so we are done now. And from graph you are having your error of 1.4659, so you can also calculate error from graph. The value of k is equal to 1.4659, 1.4659, okay, Newton meter, so -1, okay, and then from data average, okay, we have k as equal to, from data average is here, see, you have it here, f value, so you can take this, you might have it here also actually, yeah, you have it here, so just take it like this and then click here, average, so this is your average 0.39, and like that you can do this also, so you just do this also as average, and you need this one actually, just the k, so this case 0.73 for you. So I will write there that from graph, from data you are getting it as 0.73 Newton meter. Okay, now there is a vast difference, the error between both is about 50%. Okay, so you need to make, so we need to make judgment on which is more accurate value among calculated and graph. Okay, so you just have to do blah blah blah, you write all those things. Okay, so that's it. Have a nice time, and make sure you have plotted all this and you submit the work in time. So I'm going to close this down now. It's already